Hello students, this is Dr. Obhijit Shah from Chemistry Department of SRM IST. In this video, I'll describe the determination of strength of mixture of acetic acid and hydrochloric acid by conductometric method. Acetic acid is a weak acid and hydrochloric acid is a strong acid. So it is an experiment where a mixture of weak acid and strong acid will be given to you, and we have to determine the strength of weak acid and strength of strong acid by conductometric titration. So what is conductometric titration? Conductometric means we have to determine the conductance of ions. If we dissociate hydrochloric acid, we will get H plus and Cl minus ion. If we dissociate acetic acid, we will get acetate, CH3COO minus and H plus ion. However, acetic acid is a weak acid, so it will dissociate very less. So hydrochloric acid will dissociate more. So when we start this titration, titration means we need a one base NOH solution. So when we start the titration, then first hydrochloric acid will be neutralized and then acetic acid will be neutralized. So the procedure, everything about this experiment is described in this video. You may consider this video as a virtual laboratory because whatever you will do experiment in laboratory, everything will be shown in this video. I'll show you one video in next slide. Then that video you will understand everything about the experiment.
Determination of strength of a mixture of hydrochloric acid and acetic acid by conductometric titration.
The aim of this experiment is to determine the strength of hydrochloric acid and acetic acid in a mixture using conductometric titration.
This method is based on the change in conductivity of a solution due to the replacement of ions during the titration process.
When sodium hydroxide is added from the burette, hydrogen ions react with hydroxide ions to form water.
Initially, hydrochloric acid is fully dissociated into highly mobile hydrogen ions, giving high conductivity.
As hydrogen ions are replaced by less mobile sodium ions, the conductance decreases steadily until hydrochloric acid is completely neutralized.
After hydrochloric acid is neutralized, sodium hydroxide reacts with weak acetic acid, which starts dissociating into ions during the reaction.
As more ions are produced and excess hydroxide ions are added, the conductance begins to increase gradually and then sharply.
This lesson, we'll look at the conductometric titration of a mixture of strong and weak acids, hydrochloric acid and acetic.
Now procedure is explaining in this video.
The conductivity cell electrodes hang in the solution without touching the sides of the beaker. Each lead connects to the digital meter, which displays the conductivity reading in microsiemens.
Here swings deep into the red zone, showing nearly 60 millisiemens per centimeter. Inside the solution, hydrogen ions rush back and forth.
NOH is adding.
Water. When a hydrogen ion meets a hydroxide ion, they combine to form a neutral water molecule. As the reaction proceeds, the concentration of H+ drops.
Conductance drops to a minimum before rising again. The lowest point of this curve is marked here as E1. Highlighting it helps us identify.
Acetic acid begins to dissociate in water, releasing a few protons. When sodium hydroxide is added, hydroxide ions increase and quickly react with the acid.
This is the final plot of the graph we get. We can calculate the acid trend using the formula.
So this is the calculation part. Okay, so everything was described in this video. Now I will explain you this procedure already explained. So in this method, we have to take the mixture in a beaker. Then we have to add sodium hydroxide solution from the burette in a drop 0.5 ml in each. Okay, so when we are adding this sodium hydroxide, it will react with the acid solution. First, it will react with HCl, then it will neutralize the HCl, so there will be decrease in the conductance. Then it will react with acetic acid. Again, it will neutralize the acetic acid and forming sodium acetate. Due to formation of sodium acetate can be ionized, means can be, so because of this dissociation of the sodium acetate, slight conductance will increase, and when all acetic acid will be neutralized by sodium hydroxide, then in solution there will be only NOH ion. So then NOH as a OH minus is also highly conductant, so conductance again will increase. So that is the reason we are getting the graph like decreasing, then slightly increasing, then much more increase. Now this is the table. In this table, first you have to write down the volume of NOH you are adding. So 0, 0.51, 1.5, 2, 2.5 like that. And this conductance value you will get from the conductivity meter. So in conductivity meter, it will show you the value. The unit will be ohm inverse. Now from the graph you will get V1 and V2, E1 and E2. So E1 in the first point, and E2 is the second point. Now E2 minus E1 will give you the concentration of acetic acid. E1 will give you the concentration of HCl, because first HCl is neutralizing, then acetic acid. So E1 will give you the volume of E1 will give you the value, that amount of NOH required to neutralize the HCl, and E2 minus E1, that value will give you the amount of NOH required to neutralize the acetic acid. Okay, I hope you understand about this experiment from this video. Thank you all.